And right. Hey everyone, welcome. We'll get started here shortly. And Jack, we'll give it just another minute and let people join and get some people watching on Facebook. So we'll get started shortly.
Can you see if anybody is on Facebook?
Yeah, I can see. It blips on and off. The number of people watching changes from moment to moment, so it's a little hard to track, but we do see that folks are watching.
All right. Alternatively, we can just start, since I imagine most people will be watching it and recording anyway.
Yeah, definitely.
Well, we have a pretty packed agenda today.
Okay, sure. Let me just say that, this is another one of our Fix It Fair presentations. Fix It Fair at Home brings you resources that you normally find at our in-person fairs, which are still on hold while we manage COVID regulations. I'm Wayne Grabowski. I work for the City of Portland, which hosts the Fix It Fair. And I'm really excited to welcome once again Jack from Multnomah County Weatherization. Jack, thank you so much for being here, and please take it away.
All right. Hello, folks. In case you haven't attended any of my classes before, I happen to work for a wonderful organization called Multnomah County, but specifically for the program of it that is called Weatherization Program. And let me just start the presentation. And, all right. So let's. So we are the program that helps low-income families to make your houses more energy efficient, comfortable, healthy, and safe. And everything we do is at no cost to the homeowners. So the hardest part of the process is applying, but once people apply and go through the application process and they are approved, the rest gets easier. So people, either myself or one of my colleagues, comes out and does a full home energy audit. That's where we really look at the whole house holistically, how it performs and what can be improved. And from there, we create a list of measures to do to make the house more energy efficient. And then our contractors go ahead and do things that are on this list. And after everything is done, we go back and inspect it all and make sure that everything is done right. So we have some of the highest level of workmanship that you might find in the construction industry, because all of the contractors know that we check everything that they do. If you know anybody who might qualify for our program or might be interested, there is the multco.us weatherization is the best place to go. And there is a pre-screen form on there. So feel free to apply or refer to other people to apply. Today, we're going to talk about all kinds of fairly basic concepts that I believe homeowners really want to know, or anybody who even lives in a house want to know, to understand what it takes to make a house more energy efficient, healthy, comfortable, and safe, and more resilient. And a lot of the things that I'm excited about are don't even cost anything to do. So let's jump right in. I This picture is of the house. So I used to work for a program where we were certifying very high-end houses as Energy Star. So this is just a house that I was working with. And what I was seeing over and over is that on the inside, houses were immaculate, right? Like you look at this kitchen, everything's done perfectly because contractors know that homeowners know what perfection looks like and they will be asking for it. So they are delivering it. What homeowners don't know is what actually makes houses perform well. And those the sources of performance is usually found in spaces like this. And that's why there are people like myself who crawl around crawl spaces, attics, deal with mechanical equipment, and try to figure out whether things are working or not. And spoiler alert, a lot of times it's not working. So I believe that the key for us to move the whole industry in a better direction is for more people to actually understand what it takes to have a well-performing homes. That's my goal for today's presentation. So let's go right in. Our industry is really not fancy. People don't like it because of this. So there is our before and after picture is the same. After I'm done with the house, nothing visibly changes. People really like the clear before and after, but with our before and after, the feel of the house changes. Hopefully the bills change, but the actual visual stuff stays the same. So before I bore you with all kinds of interesting stuff, how about I give you a bonus that people appreciate historically that I've noticed. So if you happen to have a water heater in your house, is there anything that you can do to prolong its life? Most homeowners just accept the fact that after about 15 years, it starts leaking and there's nothing you can do. You have to throw it away and replace with a new one. If anybody, feel free, anybody, to shout out if you can, unmute yourself. If you can think of anything that can be done. My favorite is kind of a dialogue with people's participation. All right, we might not have enough people participating, but so usually when I ask that question, people talk about draining it once in a while. But no, that draining is questionably helpful at all. There is, however, one thing that people engineered and designed these things put in there. So this happens to be the top of my own water heater. And this thing right here might be a little clue that tells you that there is something going on and there is something you can do. So it turns out that all the water heaters, here's of course a water heater I cut up because, well, that's what I do. Inside of it is this interesting device. That is called sacrificial anode rod. So this is a rod. It's just a stick of aluminum, essentially, that is there to protect the actual tank from rusting. Because rusting doesn't occur just from the water contacting the tank. It occurs from acidic impurities in water attacking it. But they would much rather attack aluminum. So in order to give your water tank extra 5 to 7 years of life, all you need to do is to replace this $25 part. And it will require a little bit of labor. And as you saw, a big socket wrench with 1 1/16 inch socket. And if you just replace this part, it will be a little bit nasty. And put a new one in. And ideally, this is what I do with mine. I write down the dates when I do that right on the water heater. So I know. And periodically, I even take it out and clean this the sludge, so that aluminum actually has more surface to react with the acidic impurities. All right, here's the little bonus. Hopefully you enjoy that. Let's jump right to our energy efficiency. So this is what we covered last time, so I'll just remind people. If you want to make your house energy efficient, there's just two things that you need to do for it to contain the heat. And that is make it airtight and then insulate it all around. So you want to have a continuous boundary around the conditioned space of your house, wherever that is. Basements are usually conditioned, garages are not. So you want it to be really continuous. You don't want any holes in it. That you insulate and air seal really well. That means that all of those surfaces shouldn't have any holes and should have continuous, good, thick, fluffy, warm insulation. So that's the goal. So what does air sealing really mean? So whenever we see holes like that, like this, that this is a really bad one. Whenever we see any holes where air can be moving from the house to the outside, to the unconditioned spaces, we want to seal them. We don't want air to freely move around. And in order to test how airtight a house is, we use this device right here. This is the blower door. This is one of our biggest tools. So what it does is it depressurizes the house and it creates an equivalent of 20-mile-an-hour wind on all surfaces of the house. And that allows us, and then it has a computer and it tells us how much air is moving through. And that's how much air, how much holes there are all around. Because now all the air that's coming in can only come in through the holes. So we can actually measure how many holes there are. This right here is a device that allows us to measure duct leakage. And we'll talk about duct leakage a little bit later. Okay, so we're measuring, we know there's holes, and pretty much all the houses have a lot of holes. Okay, not all the houses, all old houses that weren't intentionally built airtightly have a lot of holes because most of them have been built with the principle a house needs to breathe. So we go into the attic and we discover things like that. What we're looking here at, this is the kind of the floor of the attic. This is the top of a wall. And usually around each side of a wall, we find two gaps where air is just moving through. Notice this black area. What this is just for decades, the air has been moving through that gap and has deposited so much little dust particles that it colored the insulation in an attic black. That tells us just how much air is moving through, a lot. So we want to seal it. So this is a seal part. This is my foam gun here, it looks like. So we want to seal it. This is what it looks like unsealed. This is what it looks like sealed. So we just hit all of those joints all around, any kind of holes that we can find. If you happen to ever be replacing your roof, do this to the exterior, tops of the exterior walls. Seal them up. That's what I happen to have replaced my roof, and those are very hard to get if the top of the walls in the eaves. So again, this is before, this is after. That's what we're going for. If we have things like that, like around chimneys, a lot of times there are huge holes just like that. We want to seal it up. We use foam board and stuff and seal it up. Done. This hole right here was probably probably has caused hundreds or thousands of dollars worth of heat loss throughout the decades of this house's life. Now that's no longer the case. Now we can insulate all over it and be done. So we were talking about attics and what we want to do in attics last time, so I'm not going to talk about it much. All I will mention again is we want to insulate them after we air seal them and prep everything in there. We want to air seal them. We want to insulate them. And the good amount of insulation is about 17 inches of insulation. So unlike a lot of people think that 3, 4, 5, 6 inches is good enough, I say add another foot to that. If there's any ducts, we want to address them and any kind of areas in there. If we see areas like that, we probably want to seal them just like this was sealed. Recessed lights and so on needs to be, again, sealed and insulated. This is what an attic looks like after we're done with it. Everything's nicely insulated, and we have about 1.5 feet of continuous blanket insulation. Really nice. With walls are much harder to insulate, but they're really important because a lot of times they have the biggest surface in the house. Insulating walls, if they're not insulated, makes the house feel like a whole different place. We use infrared cameras to check out what's in there, and then we need to drill holes every so often and insulate the walls through that. I would recommend not drilling through exterior siding like this. I would leave it as an absolute last resort. If you have any new walls on second floors, that they need to be insulated too. Any kind of doors in them need to be insulated and weather stripped. So you want that continuous membrane that is insulated and airtight around the conditioned space. Floors, same deal. We want to air seal everything we find in there. We want to insulate those pipes. We want to insulate the floor itself. And if there's ducts, we want to seal and insulate them as well. As I was mentioning last time, the biggest issue with floors is usually gravity. Gravity works against the insulation. So supporting the insulation really well is important. And it needs to be in contact with subfloor. If it's just hanging a few inches below this, this is the subfloor, this OSB. We don't want this. That gap kills the efficiency, and this insulation is probably doing nothing in this case. So it really needs to be in contact with them. And hopefully you don't have raccoons making burrows in there. This might not look super pretty, but this is actually great. This is what we're going for. We can see that it's well supported. All those nylon strings are closely attached. This insulation is not going to fall off. And it looks good. This is another good example of what it should be like. All right, people really love talking about windows. And right now, in the middle of the winter, one of the common things that I hear people say is that they feel the draft coming from their windows, especially if you have a chair like near a window. You might feel how, like I can feel right now, cold air coming from this window. So people naturally think that there is a lot of leaks, air leaks around windows. That is not the case. I do the blower door test in houses, and I have found very few windows actually leak air. However, windows are just not good insulators. Window industry has been really good at marketing their products as energy efficient. And so most people think about windows when they think about energy efficiency. In reality, windows are really low on the priority list of things to address to improve your energy efficiency. Don't think about windows. And The reason for that is that energy efficient windows are not energy efficient. There is no such thing as energy efficient windows. They are very poor insulators. So what we have here is a big cold surface, and it works kind of like in reverse of a heater. If you stand over a heater, you can feel a lot of air rising. Window does the opposite. It cools down the air, and that air starts falling down, and you feel those air currents. That's the air rotating in your room. So that air is not coming from the outside. It's the air in your house. Last time people were asking me about skylights. Are skylights any better? No, skylights are actually worse. So if you don't need to think about windows, what should you think about? The answer is ducts. If you have any portion of your ductwork in any unconditioned spaces, that means crawl spaces, attics, or garages, you really want to make sure that it's super airtight and that it's really well insulated. It will make your house not only energy efficient, that will really bump up not only energy efficiency, but also health and comfort, because bad ducts have huge opportunity for bringing in dirt into your house, reducing energy efficiency, and making your house drafty and uncomfortable. So the number of disconnected ducts I found in my career is far more than I can count. So pay attention to your ducts. This is a comparably good system, but again, remember the insulation in the attic that had black stuff around it? This is the same exact scenario. So much air has been moving through it that it discolored it. All the little particles made it black. We don't want that air loss. So we use this device, the duct blaster, to measure how air leaky they are. And spoiler alert, they're generally very leaky. If you have ducts in the floor, just lift up the thing and see are they even connected. Sometimes they're not. This is what we would rather them look like. Properly insulated and sealed. Okay. Our friend blower door comes to the rescue because this is the kind of stuff we find. And again, we're looking at the air sealing. This is another top plate in the attic. All right, chimney dampers. They are notoriously leaky as well. Talking about air sealing here. So that's what it takes to make a house energy efficient. We want to enclose it in a bubble of air tightness and good insulation. Now, comfort happens to go hand in hand with that. And the reason is because the most important aspect of comfort is the temperature of the surfaces around us. If we are surrounded by cold surfaces, even if the air is warm, we will be uncomfortable because we're constantly exchanging infrared heat between us and all the surfaces within the line of sight. So insulating all around will actually make you comfortable in your house. You can turn down the thermostat and will still be more comfortable than you did before if your walls and ceiling were not insulated and floor. So let's talk into more of the presentation I haven't covered before. Let's talk about ventilation. So we made the house airtight. We insulated it all around. Now, a lot of people have this concern, what am I going to breathe if my house is airtight? Great question. So back in the day, we were talking about the principles that houses were built with, and the principle was a house needs to breathe. So intentionally, a lot of holes were left. Now we're operating by a whole different principle, and that is build it tight, ventilate right. That means that we're trying to make a house as tight as possible and then provide mechanical ventilation. Mechanical ventilation in its simplest forms looks like this. This is a bath fan, but not just any bath fan. This is a special, energy efficient, very quiet bath fan with special controls that allow it to run all the time at low speed or every so often, like every hour it will turn on for a certain number of minutes. And however much air it takes out, same amount of air the house will suck in. And hopefully now that we've cut off the dirty sources like the attic and the crawl space, it will suck it from clean sources like leaks around windows and doors. That's another reason why I'm not worried about leaks around doors and windows. The downside is it does need to be maintained. This is inside of the bath fan that hasn't been cleaned for a few years. The mechanical ventilation does need to be upkept and maintained, otherwise it stops working. Here's an example of what I did. I took a bath fan. I have 3 ventilation systems in my house. One of them is this bath fan that I was experimenting with, and I set it up very close to the floor in my basement, and found that it decreases the radon concentration in my house by about 30 to 40%. So I'm just sucking off the air and throwing it outside right from the floor of my basement. I apologize. But the more complex ventilation systems would be balanced ventilation. They bring in air and take away air. They are much more difficult to properly design and build, provide better efficiency, but so this is the actual core of it. So there's 2 airflows moving through this way and that way and exchanging the actual heat. So the air that goes out has the heat out of it extracted into the air that comes in. So you're not losing a lot of that heat, which is great. But it does require a whole different level of engineering and maintenance. Here is a simple form of balanced ventilation. In fact, this very thing is, it's called a spot ERV. There's just one manufacturer that helps. That thing happens to be right there. That happens to be ventilation system in my own house. And it works pretty well. Do we have any questions at this time? Let's see.
Any questions on Facebook yet?
Okay.
Feel free to drop questions in the chat. For those of you watching on Facebook, you can write in the comment section. We'll make sure your questions are answered as well.
Wonderful. Yes. And pretty much, if you're brave enough, you can yell out questions if you feel like. All right. Let's go right back in here. Oops. Oh, no.
Jack, I'll just let you know that not all the attendees have the ability to unmute, and that's beyond my control. So if folks do have questions or comments, feel free to hover over the Zoom screen. You'll see a chat pop-up box, and you can type in questions there.
Perfect. Thank you. All right. So the spot ERV only has 2 pipes going to it. So it's easier to install as opposed to 4-pipe usual balanced ventilation. Well, what other ventilations can we think about? This is an actual picture I took at a friend's house. This is what she uses whenever she cooks in order to extract the air out. Obviously, probably not very effective, because if you're taking air out far away from your cooking space, it's not very effective. So something like this works better. But you know what works even better? Something like this. You might notice this is the same space. I did help a friend of mine install a range hood. And this one that extends further and is closer to the surface will work better. Besides, it's a better range hood that actually moves more air. Here is a little cool tip. Do prioritize using back burners whenever you cook. it will allow and use the range hood that takes air all the way to outside. So make sure that you have a range exhaust uh, fan that takes air to the outside, not just the one that's recirculator. Recirculator doesn't do anything. We call them forehead greasers. They just throw it right back at your forehead. So make sure you have a good range hood that takes air to outside, and prioritize back burner use. Back burners, when you cook on back burners, much more of the particles that you don't want to be breathing will be captured. And even if you're not running a range hood, just having it further away from you will actually improve the air quality somewhat. But if you're running a range hood, it will make a noticeable difference in concentration of particles. And particularly if you happen to have a gas oven, those things are particularly dangerous. I say absolutely make sure you have a good working range hood in that case, and absolutely always use it whenever you're using the oven specifically. Here is a concentration of carbon monoxide that I'm routinely testing in those things that is life-threatening pretty much. So especially first 15 minutes or so when they're warming up is particularly bad. So when you turn on a gas oven, try to not even be near it. And let's talk about heating. So people talk a lot about efficiencies. I notice efficiency happens to be a buzzword. However, I like to talk about how much does something cost per dollar, or how many dollars does heating something cost? Because people think efficiency correlates with it. In reality, it doesn't. So here is a little graph that I made. It was years ago, but still is relevant, and similar things are still true. So each of these is is amount of dollars that it takes to heat an average home using different fuel sources. So what kind of fuel source that you use at your house to heat your house will affect your bill probably more than anything else, and more than the efficiency that you're running it at. So here, for example, is gas furnaces. This is a fancy 90-some% efficient, pretty much as efficient as they get. This is how, and heating the house will take, well, back then would take, say, $500 or so. If this is the least fancy, those are old, we don't even see gas furnaces this inefficient anymore much. Most of them have been replaced by now. But even if you had a really inefficient gas furnace, it would take $600 and something, right? But if you were heating the same exact house with 100% efficient electric heaters, your cost would be about $1,600. How is that? Right? That's why I don't bother talking about efficiencies as much as talking about how much money it will actually take to heat it. Because ultimately, we probably care about money more than we care about some kind of irrelevant percentages. Now, is there a way to use electricity and do it efficiently, heat your house efficiently on a budget? Yes, here is the answer. And we'll talk about it in a bit. It's heat pumps. Now, if you're using oil, and we'll mention it in a bit, it will still be quite expensive. Oil is not cheap. So not quite as expensive as electric resistance heaters, but definitely much more expensive than heat pumps, and come with a bunch of other problems. So gas is one of the most prevalent fuel sources around here. So let's talk about gas furnaces. Usually, historically, if you happen to have gas available wherever you live, it's a no-brainer. You just install a gas furnace, done. So what it does is, so here is a heat exchanger of a gas furnace that was pulled out of it. So that's like the heart of of the furnace. Inside this zigzaggy metal pipe is the actual flame. That's what the fire is burning. And the air that it gets circulated throughout our house is moved right through this grill. So the two turns are never connected, right? So we're burning the gas inside there, and the exhaust goes to outside, but the air that we're actually breathing is never mixing with it. It's only touching it and taking away the heat from it, but it doesn't mix with it. So we really don't want to be burning. We don't want to be breathing those combustion gases. And this is how it's done. This is the heart of a furnace, heat exchanger. That's why whenever you hear holes in heat exchangers, right? Like if it develops holes, that's probably the time to replace the furnace, because then the combustion gases can be mixing with it. So, oops, let's go. Well, how about here is an oil furnace. And sometimes we see really prehistoric cases like this one. We did replace this one, but this one was a really old one, about 100 years or so. They, what do I want to say about oil? Oil is a term the heating industry invented to market their product. In reality, if you have oil heat, it's actually not oil that you're burning. Oil is something that I think about when I put dressing on my salad or change oil in my car. That's oil. What we burn in those furnaces is diesel. So this is exactly the product that you buy at a gas station. So I am really not a fan of oil as a way of heating homes. It's very polluting, inefficient, and it's just not excusable in 22nd century. Now that we have heat pumps, if gas is not available, we have heat pumps. They are actually probably cheaper than oil furnaces and definitely better across the board. They are cheaper to run. They don't require any hazardous chemicals in your house and so on. So I'm looking forward to all the oil heat being replaced with cleaner, more sustainable sources of fuels in the short future. So let's talk about electricity. So there is two ways of producing heat using electricity. And remember, the first one of them was very expensive. This is what we're looking at here. If you have baseboards, if you have any kind of space heaters, if you have cadet heaters, all of them are forms of electric resistance heat. A light, like an old school light bulb, or even the computer or any kind of device that you're watching this video on, are all forms of electric resistance heaters. A hair dryer is an electric resistance heater. They are 100% efficient. There is no way you can improve their efficiency. So when you go to Home Depot and you're looking for something that says, which one is the infrared, quartz, or energy saver, something like that, well, know that they are all producing same exact amount of heat per dollar, even if they're 40 years old. So sometimes you can find a website like this that talks about most energy efficient space heaters. And now you can laugh at it because you know that it's absolutely bonkers. They are all same exact efficiency. There's no way to improve it. So there is one way to get much more heat per dollar using electricity. And this is actually the area of the biggest developments now and looking forward. This is the technology that's still pretty young. It's already very impressive. And it still has so much to do. Like, we pretty much maxed out on all of the technologies, on gas, on electric resistance, on burning, pretty much burning anything. We're already getting all the efficiency that we can get out of it. However, on heat pumps, we're still just scratching the surface. They already are competing with the most efficient gas furnaces, but they can still get quite a bit more energy efficient. Theoretical maximum is still stratospherically high compared to where we're at. And they look like different things. Like these are mini split heat pumps. This is the unit that goes on the inside. This is outside, or they look just like regular furnaces. Benefits of them is also that they all do air conditioning. So if you have a heat pump, that means you have air conditioning. Congratulations. Other technologies that allow heat pumps to shine is heat pump water heaters. So if you're considering replacing a water heater, you might want to think about saving money on your water heater, especially if you're using water a lot. It might make a difference in your bills by heating up the water using heat pumps. And heat pump dryers, something that in our country is very new so far and not well known, but they don't need venting. They use about half of the electricity that regular dryers use, and however, they do take about twice as long to dry clothes. And particularly exciting, I would say, are heat pumps that go into windows. So they look just like window ACs, but if you live in a rental, or if you have an apartment where you can't really do much, and your heating is electric resistance like cadets or baseboards, and you're tired of high bills, you can stick one of those in the window and run it in the heating mode, and your heating bills might be about half of what it used to be. They do cost more than window ACs. Like a unit like that, last time I looked, was about $800, but depending on your bills, it might pay off in a couple of years. Oops. All right. So heat pumps don't produce heat. They take it from outside, which is a little counterintuitive, but say it's 30 degrees out. It cools down the air from 30 to 20 degrees and takes that heat and puts it inside. And that's how they're able to be 3 to 4 times as energy efficient as electric resistant space heaters. All right, I do see sometimes people who think that there are ways around physics and there is ways that we are being not told the truth, and there's ways to heat spaces cheaper, like this flower pot heater that costs just 4 cents an hour to run. And they propose you put in candles in the flower pots, and somehow it's really great. And the worst yet, it got millions of views. So whenever I see stuff like that, my blood starts boiling a little bit. I did the math and calculated that it will cost about 8 cents an hour to run in reality, based on the candle prices. And it will produce a lot of carbon monoxide right in your house. And then 8 cents an hour, it doesn't sound like a lot, but when I did the calculation for my house, if I were to heat my house using these candle things, it would quadruple my heating bill easily, maybe even more. And those flower pots actually do nothing. You can just put candles all the way around, and they'll do exactly that. But it's really not cheap. Alternatively, I also see sometimes air conditioners made out of ice. They propose you go to the store, buy a bunch of ice, and then cool your house using a fan blowing across it. And they say it's energy efficient. It's completely bonkers. I did a calculation of how much electricity does it cost does it take to heat one bag of ice that you buy for $1.88 right now at the store? And the electricity that it takes is actually less than 1 penny. So when you're buying a bag of ice, the electricity that has to produce that ice is less than a penny. Just consider that. But let's talk about what's important for you to know. So if you have a furnace, a heat pump, anything that moves air through it, most important thing you want to do is make sure that filter is replaced regularly. Yes, I find filters like this not infrequently, and people didn't even know that they have one. So yeah, filters like this, you really don't want to have a filter like that in your house. Don't do it. Now, some people go the other way. Is this good? No, it's not. Now it's creating extra resistance for your filters. One filter is all you need. Don't have two, don't have zero, have one. But make sure that it's in there good and air cannot bypass it. All right, let's talk a little bit about a couple of years ago, we had these really bad forest fires. And this is the picture I took at Home Depot right at the beginning of it. It didn't even hit us yet, but all the air filters were already bought out. The next day, I went to the same place, and absolutely all filters were absolutely completely gone. These shelves were just empty. So when people ask me how to prepare for those events, I say have a HEPA air purifier that you just store when you don't need it, but when you need to, button down the house, just close it off, turn off all the fans that are blowing air outside, and run a HEPA air filter inside. And you might want to consider storing a really good, like high MERV filter for your furnace and running it just on fan only during those times. That is given that your ducts are not leaky and not going through garages, crawl spaces, and attics. Because if they are, you might actually be sucking in more stuff in than you're doing good. And also, why am I not recommending running MERV 13 or better filters all the time? Well, because they create a lot of resistance on your furnace. And running it on just a fan is fine, but trying to run it on heating for furnace systems that are not built for it might actually not be good for your whole furnace system. They might not be able to keep up. Okay, people ask me, how often should I have people look at my furnace and do annual maintenance, right? Like heating companies tell us that they need to come in every year and look at it. If your furnace looks like this, yeah, seems like a good time to do something about it. But generally, it's hard for me to recommend doing it all the time because it's if you have trusted contractors that you know are doing something meaningful, do it. Otherwise, what I see people do most of the time is when something's broken, they call in somebody. If you do maintenance and you're wondering whether they're doing anything meaningful, ask them a couple of simple questions like, what was the carbon monoxide reading, for example, in my combustion gases? Or ask them, what was the total static pressure in my ducts? And if they're not able to answer those questions, well, they're probably just vacuuming it out and calling it good, or who knows? Okay, does anybody know what we're looking here at? All right, if you have an outdoor unit, like a air conditioner or a heat pump that sits outside, and you happen to have some dogs, do not let them pee on it. This is what will end up happening. In general, if you have bushes or other things in there that prevent airflow moving through it, trim them back, make sure that air can flow through those whole units. My personal pet peeve, portable ACs. These things, people thought that are the coolest thing and way better than a window ACs because they're more expensive. They seem like a newer technology. They are not. They're not any better. I would say try not to use these if you can. If you use a window AC, it'll be cheaper and actually far more energy efficient and will cool your house much better than one of these. If you have outdoor units, one of the things to maintain is to make sure that it's clean, right? If you have a big buildup of dust like this on the grill, air is having a hard time moving through it. It's good to clean it, but be very careful. Those fins are very sharp. Don't use it. Don't use your fingers. All right, dryer venting. So if you have a helper, little helpers, they can inspect it for you. And you want to make sure that the termination outside doesn't look like this. You're probably laughing looking at it as it seems obvious, but this is a real termination that I found somebody had, and they lived like that for a while. If you see, just look behind your dryer, see what the dryer vent looks like. If it's made of this white vinyl, replace it. That stuff is dangerous and doesn't work well. If it looks like this, replace it. See where it goes. If it goes in a crawl space and is broken in there, well, probably replace it too. All right, let's talk about light bulbs. Oops. I actually brought the props today. So, let's see. So sometimes people are confused about lighting and what kind of light bulbs to use. So these are the light bulbs we all grew up with. These were great. They produced actually great light, but consumed a lot of electricity. In order to combat that, these things were invented, curly CFLs. People didn't get a good taste of energy efficiency from these. Congratulations, you never have to use these light bulbs again. If you still have these, you can replace them with LEDs. LEDs come in all kinds of shapes and forms, but generally they are even more energy efficient than the curly ones. And they took off all the drawbacks of the CFLs. And now they're cheap enough that there is no good reason to use anything else. So I say, use it. Let's jump back right to the presentation. Okay, let's say you have a water heater in your house. One thing you want to do is you can touch the venting of it. If something like this happens, you want to hire somebody to properly screw it down. This is not good. It should not be like that. That venting is there to save your life, and it needs to be in there securely. Otherwise, it's just dangerous. And it's not uncommon. All right. What is this? Those carbon monoxide detectors. I recommend the ones with digital display. They will show you highest level ever recorded. I really discourage anyone from using what they call air fresheners. These things don't freshen air. They only dump more chemicals into it. And particularly if you have anybody sensitive to air quality in your house, like people with asthma, these things are horrendous for them. Here we're looking at a floor in a crawl space. That might be the biggest source of moisture. In general, if you have moisture, there is a good range of moisture. And I recommend anybody using a device that looks maybe like this to check what your current moisture relative humidity level is. You want to be somewhere between 35 and 55%, more or less, right? If you're way above 60, you want to start looking at what's going on and how to combat that. Because if you have too high of a relative humidity, you might end up with condensation and mold. Cleanable surfaces is this really good concept in healthy homes. So if you have somebody who's sensitive to air quality, you want to have as many cleanable surfaces. That means this right here is a cleanable surface. This wall is a cleanable surface. All of this is not cleanable surfaces. Like that is cleanable. This is not cleanable. I mean, you can clean it by using a vacuum, but it's difficult and never going to be truly clean. If you do use a vacuum, make sure that your vacuum has a HEPA filter in it. Otherwise, you might be throwing tiny particles into the air that are actually particularly bad for us and maybe making the problem worse. So don't use bad vacuums. Make sure that they have really good filtration systems. And then in general, when cleaning, I say between vinegar, baking soda, Dr. Bronner soap, you can clean pretty much anything. I was shocked at how many chemicals people use in this country when I moved here. Like you generally, I think it's safe to say that most Americans can reduce their chemical use by 90% probably, and be actually better off. Health-wise, environmental impact-wise, and actually cleanliness-wise. So, all right, a little bit about the scams that I see around. Whenever you see radiant insulation being advertised as something really cool, don't believe it. This is what you will end up with, or something like that. Radiant insulation is developed by NASA. Yes, it was. It works really well in space. Absolutely unnecessary in most cases in houses. Any kind of devices that supposedly save energy by being plugged into an outlet are a scam. They don't work. Ghost loads, something that we hear a lot about, we can do in order to improve. I've seen claims that 30% of our energy consumption is ghost loads, like when things are plugged in and they are off, but they are supposedly consuming electricity. I've actually tested out the consumption of devices in their off position. Most of them don't consume anything. So I wouldn't worry about it too much. There is generally bigger fish to fry in majority of houses. And again, apply to our program if you think you might qualify, or bring people in who might. We'll be happy to help. And thank you so much for participating. Let's see, we have a couple of minutes for questions. Are there any questions, Wayne?
No, I don't see any. And I have dropped some of the resources where folks can reach out to us into Facebook. So if people do have questions, they can reach us at a later time as well. And there's always a little bit of a delay on Facebook as well, so we might just sit tight.
Oh, I
do see a little question in the chat.
Yeah. What about renters and apartments? So the window heat pump is one thing that I would recommend as very much unknown strategy. So if people, in most cases, people who are renters paying exuberant amounts of money for heating because their landlords have no interest in investing in energy efficiency heatings, right? They're not interested in spending money on heat pumps because they're not paying the bills. And cadet heaters and electric resistance heaters cost very little to install, but cost a lot to operate, as opposed to heat pumps. So window heat pumps might actually be the best solution for those. All right.
So
All right, looks like
drop that into the chat there so folks knew how to reach us afterwards as well.
All right, looks like Wayne, you yourself said that portable AC is the only one you have.
Yeah, I'm in a
Well,
rental house and there's not a really good opportunity for a window unit, and of course doesn't have AC. So we call it the R2D2.
Yes,
Droid unit.
Well, if I would invest my time, well, being a handy person, perhaps, I would, do you have sliding windows? Is that the difficulty?
Yeah, we have sliding windows.
Right.
And a request from our landlord to not place a unit on the front of the house as well. So we have a fixed lower window on the front of the house anyway. The window that makes the most sense upstairs is on the front of the house. So it otherwise limits our ability to place a AC unit.
Yeah, that's tough. Well, sorry to hear that.
We'll make do with our droid. We have a few more questions here in the chat too.
Let's see. I just bought my first house and I cannot find a furnace. Where do I find it, or who should I call? You cannot find a furnace in the house. I have a cadet in every room and gas for hot water heater. Okay, well, you don't have a furnace. You have a cadet heater. So what I talked about in electric resistance heat applies to you. So your house, as you probably already discovered, will cost you an arm and a leg in electric bill to heat. If you want to change that, you want to invest into installing heat pump, and that will drop down your energy bill significantly and will provide you with air conditioning. But what you want to do alongside of it is get a home energy audit and insulate and air seal the house and do all the things that I was talking about. Let's see. So great questions, Dominique. And Zach. Yay. All right. Well, thank you, folks. I hope, feel free to write what you think of this presentation. It was the first time that it was presented in this form. I just kind of put it together. So if you write this comment, I would appreciate it. And thank you so much.
We also have a survey that we send out that you'll have the opportunity to give input for the workshop too. I know it's hard to give input on the spot and also when you're not anonymous. So we can, everyone will get that automatically sent to them and be entered into a raffle to win a gift card as well. So keep your eye out for that. Jack, thank you once again. I'm sorry. I can't be on camera. Oh, we have a comment there in the chat.
Yeah, $300 is not even that surprising for an all electric house. I've seen way worse. Yeah.
All right. Well, thank you everyone for joining. Another great presentation, Jack. Thank you so much.
Thank you, Wang, for your support.
Absolutely. Glad to. All right. I think we'll sign off. Bye for now, everyone. Thank you. Have a good night.
Bye.